Thank you all for being here. Very last thing of the day, we're going to talk about our 7-year and counting success story with ontologies and knowledge graphs at Morgan Stanley. Little bit of background about my employer first. Please be kind, my boss is in the room. Semantic Arts is a small professional services company, and we specialize in semantic technology, helping our clients to create ontologies and knowledge graphs based on those and move toward a more data-centric future. Data centricity is the topic of an entire conference hosted by Semantic Arts. I'm not going to go into that today, given the limited amount of time we have. But to date, Semantic Arts has created and fielded 50 enterprise and domain ontologies for various clients. And in the last dozen or 7 or 8 years, we've really moved into the knowledge graph implementation of those ontologies. We have, at this point, actually closer to 20 ontologists on staff, making us one of the probably largest collection of weirdos you're going to find in this space. Myself, I am Dan Carey. I'm one of the senior ontologists, as you can tell by the gray hair. I've been working in the knowledge, in the data modeling and application database design space for 30 years. I first learned about semantics at a DAMA EDW conference in 2006 from my now boss, Dave McComb. I began to actually get to do semantic modeling primarily for government clients beginning in 2011. But for the last 8 years, as of last Friday, I've been living the dream, creating ontologies and knowledge graphs for clients in Semantic Arts. Before I dive into the real meat of the talk here, though, I did want to go through some terms that for those of you who might not be familiar with the semantic space, and for those of you who are, I'm sort of clarifying the manner in which I'm going to be using the terms, starting with ontology. An ontology is a model, or if you prefer the word schema, about things, broadly, things, and the relationships between those things. And then we capture that in a formal manner using the OWL language, the Web Ontology language, which is a standard promoted by the World Wide Web Consortium, the W3C. When I'm using the word data today, more often than not, I'm going to be talking about RDF data. And what this is, it's assertions about things and the relationships between those things captured in the form of triples, and a triple is kind of a little sentence, like a subject, a predicate, and an object. And these triples are captured in the resource description format, RDF, which is again a standard promoted by the W3C. A triple store is a database that is optimized for storing and querying RDF triples. The platforms will do other things for you, but for our purposes today, that's what's important. Then a knowledge graph, because I'm using the word today, is a combination of one or more ontologies and data expressed as triples stored together in a triple store. Key to a lot of what's going on here is the IRI. This stands for Internationalized Resource Identifier. Its predecessor term was Uniform Resource Identifier, but they changed the standard so you could include non-Western characters in these identifiers. There was a really cool article by Bob Ducharme where he showed you could create IRIs using emoticons. But the IRI is an identifier that is intended to uniquely identify one thing and one thing only. Now, this thing that is being pointed to by this identifier can have more than one identifier pointing to it. It's not an ideal situation when that happens, but it happens. It's the real world. So And then namespaces, especially if you've worked with XML, you're probably familiar with this. But a namespace is a logical grouping for IDs, or the basis on which you build IDs. And here, when we're working in the W3C-based space, these namespaces are based on web domains, the .coms, the .nets, and so forth. And a named graph is just a collection of a bunch of RDF triples that's got a name applied to that group, and it's within the triple store. So, any questions on those terms before I move along? Yes?
So for the IRI, is that a unique identifier, or is that
So it's unique in the sense that the IRI identifies only one thing, but it's not necessarily unique in the sense that things can only have one IRI, because they can have more than one IRI. When you are when you've minted an IRI for a thing in your own system, well, some other knowledge graph out there might have a different IRI for that same thing. So, the Eiffel Tower, will have multiple IRIs from different systems, but within each of those knowledge graphs, that IRI would be unique. Yep.
what is the difference between a subject and an object?
So in this little sentence, and we're going to get to a thing later, but we're employee XYZ is assigned to organization JKL. So subject, predicate, object. Okay. All right, so let's move on to the real story here. And I'm going to grab water because I was up in my room rehearsing this and looked at my watch and said, crap, I've got 7 minutes to get downstairs. And that left me breathless. Morgan Stanley, our client, as hopefully most of you know, is a large financial services firm. And they have involvement in a lot of things, investment banking and wealth management for both individuals and institutions, securities trading, that includes like the e-trading you can do at home yourself. They do a lot in the financial services space. But we were brought in not for that main trading financial services part. We were brought in by a gentleman who was their new head of information management. Now, it's important to note that here in Morgan Stanley, information management is an activity of the legal and compliance department. It is not an IT activity. This has to do with knowing how long you're supposed to retain information in the various countries that Morgan Stanley works in, how you're going to deal with PII and implement all of the various other policies that laws and regulations might require. So Semantic Arts was brought in by this gentleman as part of his initial strategy to leverage knowledge graphs and natural language processing and machine learning to help wrap their arms around the huge volume of information that they have to manage as part of information management. So Semantic Arts came in, and for the pilot, we created an ontology that is based on GIST. More on that later. We converted pertinent data from multiple different systems and transforming that into RDF triples. We gathered and converted some data from outside the firm that was going to be useful for what he wanted to try. And interestingly, some of that data conformed to a pre-existing publicly available ontology, so we grabbed that too. And then we loaded those ontologies into a triple store. They already had an XML database there at Morgan Stanley, and it had a triple store capability within it. So we were able to swiftly move ahead and get the stuff in there. And then we would write the queries to demonstrate the potential power of this knowledge graph NLP approach. And key from our viewpoint was that we did all of that. Where's my? There, 4 months. 3 people, 4 months. We managed to get all of that done. So the information manager was pleased and said, yeah, let's definitely continue moving forward. And so we've been expanding the ontology and adding new data sources and everything as we went along. Now, of course, your colleagues talk to one another. So as a consequence, other organizations in Morgan Stanley heard about what was going on, and they were intrigued. This knowledge graph thing, let's learn more, maybe see what we can do. So this is the first important milestone in our journey, which was that our client, the information manager, realized that the more people, the more organizations within Morgan Stanley that had knowledge graphs, the safer his program would be, because it wouldn't be such a weirdo. But also, more importantly, the more linked data you have available, the more links that you can make within your knowledge graph, the stronger the thing becomes, the more valuable all of that data is, much more than it is in isolation. So he decided that he would sponsor Semantic Arts to go work with these other organizations to create a pilot knowledge graph for them, to let them see if that was something they were really interested in pursuing. And if so, then they would then fund the knowledge graph work themselves. But he's paying for all of that out of his own pocket, out of his own budget. Very unusual, but a little bit of self-interest there, because as I noted, the more knowledge graphs there are, the more valuable the data are. So consequently, Morgan Stanley now has 10 different knowledge graphs, either in production or in fairly far along in development. Now, having all of these has led to some interesting questions around governance and interoperability, and that's really the meat of what I want to get into today. Milestone 2. So right after we had 2 knowledge graphs, we had the information management graph, we had the operational risk knowledge graph. Both of these were built based on GIST. They import GIST, they use that as the basis from which they expanded. GIST is an upper-level ontology that Semantic Arts has created and maintains. It's intended to cover pretty much any business concept or activity that you would want to model inside a knowledge graph. And it is focused on business. We're not trying to model the entire world the way some upper ontologies are. But it's also kind of small, hence the name. And we make it available free under a Creative Commons license. You can go onto the semanticarts.com website. There's a little GIST link. You can download it, have fun with it, go make your own stuff. And we're off. I am? Okay, good. The client decided that they wanted to purchase the rights to create a fork off of GIST and change its name, and more importantly, change the IRIs within it to use the web domain base that's under Morgan Stanley's control, which interestingly is ms.com. How they beat Microsoft to that, I do not know, but they did. And so this fork became known as the core ontology. do want to note that one of the things we've noted when we got to Morgan Stanley, but we've seen it in other clients as well, when you use the term upper ontology, in some people's mind, it creates this perception that their ontology, their specialization of it, is somehow less. It's not as important because it's not upper. So we instead prefer using the term core because in some people's minds that creates the impression that your ontology is surrounding it and subsuming it and built on top of it. And this gives you a better sense of the importance of your own ontology, that it's not in a way subservient or whatever to an upper ontology. So the core is the way we go. And this plays into the psychology of when you're encouraging others, come use our core instead of, come submit yourselves to our upper ontology. Once we had more than one knowledge graph, we wanted to ensure that they were going to be interoperable and to do that, be able to do that easily, no forcing. And by interoperable here, what we do not mean putting all the knowledge graphs into the same database, into the same triple store. Because there's a lot of reasons not to do that, some having to do with entitlements and security, some having to do with performance. But what we want is to be able to seamlessly use the data between the different knowledge graphs. So again, our client, who's an exceptionally perceptive guy, knowing the culture in Morgan Stanley, knew that if we wanted to encourage use of the core as the basis for these new knowledge graphs, coming in and saying, you have to use the core and you have to do this thing in order to get admitted to our club, that was not going to fly. People would be resistant to that. So instead, we had a kind of a sales pitch. Hey, we got this thing, come use it. It's it's proven and it's free, and here's all the things you get when you use it. You get a starter model, so you're not having to start from a blank sheet of paper. So automatically you're a bit ahead of the game. You're not having to spend time and burn budget going from zero. You get some data, some common data that you can immediately put into use that, again, you don't have to worry about sourcing, you don't have to worry about converting. It's there, it's free, you're good to go. And when you're developing your applications on top of the knowledge graph, we've got people with experience doing that, and you'll be able to talk to them because they'll understand what it takes to work with the core and this sort of thing. So it was very much a, come play with us, be in our space. This is a good thing. But that said, we don't want to interfere with your own ontology. It's yours. You should have control over it. We just want to make sure that everything is, playing well together. I want to encourage that. Which then led to milestone number 3. What do you do about the core? It's going to evolve. It's going to need to evolve and change. So we determined that no single organization, no single domain should control the core by themselves. Instead, we created a consortium of organizations, which we call the Ontologies and Semantic Modeling Consortium, the OSMC. And the OSMC is charged with these bulleted items here, which is encouraging adoption of the core, first and foremost. Anybody who's going to create an ontology in Morgan Stanley, we really, really, really want them to use the core for interoperability purposes. The consortium is charged with approving any changes or extensions to the core. And we're also wanting to promote some consistent minting patterns around IRIs. And I'll talk a little bit about that, and some triples patterns. And if there's a possibility of conflicts over namespaces or class names, definitions, and this sort of thing, the consortium would be the correct place to resolve those kinds of issues. And anybody can attend a consortium meeting, but voting membership is limited to an organization that is actively developing a core-based knowledge graph, or has one in production. One of the key things we tell people when they join the consortium is your primary responsibility when somebody comes in and says, hey, I got this new stuff, I want to put it in the core, is to say no. And the reason for this is just as GIST, its progenitor, is small, we want to keep MS Core small. And currently it's 219 classes, 243 properties, which, when you think about an enterprise level model, that's pretty compact. So this size and the way it's constructed gives new developers the freedom to craft their domain ontologies in a way that's appropriate to their context and supported by the core, but not unduly constrained and limited by it. It's not a tight box, and it's that way by design. We want the core to be stable so that the people who are using it have some confidence that it's not going to be constantly changing underneath them and disrupting their knowledge graphs, especially when you've got something in production. You really don't want a lot of churn going on. So again, say no. And after 7 years, most of the structure of the core is largely unchanged. And interestingly, the one really kind of big structural change we made had almost no impact on the actual production level queries and stuff. So, it was more like to satisfy the ontological nerds, that we want to rearrange this because it makes more sense for us. I mentioned that we provide some common data. We could call it reference data. I always hesitate to use the word master data because it's such a fuzzy term, but it's the enterprise level kind of data that everybody uses, everybody needs. So we've got the Morgan Stanley organizational hierarchy in there, so all of the organizations. We have all of their personnel along with their various IDs, their email addresses, the organizational assignments, what country they're located in, all that kind of stuff, but not, the fiddly PII stuff, no tax IDs and driver's licenses and such. We capture the information about the thousands of legal entities that Morgan Stanley creates in order to execute their various agreements around the world. And we have geodata from a system that's got identifiers for all of the countries and states and provinces and cities and so forth, and various aggregations around that. But we supplement that internal geodata with some external data that is created by geonames.org, which is available in an RDF format natively, which is really nice and for a really cheap price at an annual rate. And so, the nice thing about that GeoName stuff is it enhances and enriches the data so that when you do have an application sitting on top of this stuff and you want to link out to something, you can get a map up and other stuff that you wouldn't have with just the purely internal geodata. And apart from the GeoName stuff, all of this gets refreshed from the legacy systems, from the source systems on a daily or weekly basis, kind of depending on the nature of that data. And it is up to each individual domain to choose how frequently they want to refresh the data in their own knowledge graph. So, depending on your own use case, you can let stuff get stale for a month if you want. The key thing that we get, though, from this common data, and the most important point as far as I'm concerned, is that the data sets ensure that we're using consistent IRIs across all of the knowledge graphs that are using the core. So employee XYZ is the, that identifier is the exact same meaning everywhere, and they really shouldn't have another IRI associated with them. If somebody does that, we have a talk. We don't say you can't, but we have a talk. So these consistent IRIs are dependent upon the use of namespaces. All of the IRIs are built around namespaces. And the creation of namespaces depends upon who's governing something. So we said, all right, any organization that's got responsibility for a defined, bounded business area can be responsible for creating a namespace and managing that. Early on, we tried to get a little more definitive about that. Oh, well, it should be up the division level, or ultimately that proved fruitless. But this idea of a defined, bounded area, but not necessarily a particular organization. You don't, because organizations change, whereas the business, the nature of the business is pretty stable. So you want things, namespaces built around the business areas, the business activities, rather than an organization. And the other key thing is that all of the namespaces have to be based on that ms.com web domain. So we've got a multiplicity of namespaces now, and this allows each business domain within their ontology to define the classes and the properties and create the data structures that are appropriate to their context. And while the example I'm going to throw out here doesn't apply in Morgan Stanley because we don't have these knowledge graphs, but you could have a class called credit in, say, the training namespace that would have one particular meaning, and you could have a class called credit in the accounting namespace, two completely different concepts. But because all of the IRIs using those things are coming from different namespaces, they could appear in the same knowledge graph and not create confusion. So, always nice. So it's appropriate to their context. It does not interfere with other domains' data, but it allows you to interoperate with other knowledge graphs' data and their ontologies. And when I'm building my ontology or expanding my existing ontology, and that ontology over there has a really, really good class already established for something that I want to add into mine, I can just reference that and pull it into my ontology and not have to, worry about colliding definitions. So the consortium also has other guidance that we provide, and the guidance is built around some certain basic principles, which the first of which I already articulated is we want you to keep your ontology small. And the reason for that is we want it to be understandable for your people. We want them to be able to look at their ontology, or which hopefully they're thinking of it that way, but say they're coming from outside and looking at your ontology. We want them to be able to understand that and really get familiar with it in a matter of 2 or 3 days. So most of the ontologies that we've got have a total of classes and properties 200 to 300 items, not much more than that. Some of them are much smaller than that because the core is covering so much of what they already need. We encourage human-friendly designs for the RDF data. This means using informational IRIs, more on that, providing visual cues to the humans to indicate what the IRI is about, what it's referring to. And make your triples sound like a sentence. When you say it out loud, does it sound like gobbledygook, or does it sound like something that an actual person's going to understand? Put an IRI on as many things as you possibly can, and put those things into the knowledge graph, because the more things you have in the knowledge graph, the more knowledge you have, and the more things you can link to, and the more things you can say about those things. So, some of the things like the named graphs, for instance, some people would not necessarily think of putting an IRI as the name for the named graph. And yet if you do, now you can say things about the named graph. When did we last load that? Who personally, who was the user who loaded it? That sort of thing. And most important, any of the names you're putting into your ontology and into your knowledge graph should have meaning to them. You do not want to just duplicate names from the tables and columns that you're receiving data from. The reasons for that are many, because a lot of tables and columns have really cryptic names. How programmers love to squeeze as many vowels out of a thing as they can and make it small, because God help if they should have to type a few extra letters. But you're not necessarily going to know what that is. You could have names of columns in different things that mean completely different items. You can have multiple column names for the same thing. It's just a really, really bad practice. So, and there are tools out there that say, hey, we can help you convert your relational data into RDF, create an ontology like that. No problem. You get what you don't pay for. That is not the way to go. So make sure that your things have meaning. For those of you who aren't familiar with ontologies, I apologize. I don't have time to kind of explain what this means. But for those of you who are familiar with it, we advocate not putting domains and ranges on object properties. And the reason for this is when you add those kinds of constraints, you're automatically limiting the number of places you can use that property. Whereas if you don't have that constraint, you've opened up the number of places you can use it, so you're not having to have multiple specializations of the properties. You can go with that more open thing. And this also, in turn, helps keep your ontology small. Now, the IRIs themselves. Some knowledge graph designers, especially those, when they have the rubber's hitting the road and they're having to mint data, they like to create meaningless or information-free IRIs because they're easy to mint. And usually this will mean relying on something like a GUID. I've got an example here. I don't know about you, but that's just ugly. How are you going to tell me? Oh, I was looking at P0RSNG, capital GQ, capital H7. No, that is just, that way madness lies. You don't want to do that. Instead, we prefer being able to tell at a glance what this IRI is about, what this individual is. And you shouldn't have to have the IRI and a label, because you're not always going to have access to that. You should be able to look at a triple in isolation from anything else and be able to know what that triple is about. What is it saying? And both of these things apply, especially when you do not have access to the rest of the knowledge graph. You're not able to query these things. If you're looking at an extract of triples, you should know what's going on. You shouldn't have to rely on something to decode a GUID. So let's compare this little triple here, where our subject, we've got this prefix. This EX just stands for example. That's the namespace I'm using there. But in Morgan Stanley, there would be a more meaningful ms.com based namespace there. Then we've got at the end here what we're calling the suffix, and a string that is actually an identifier received from the system of record for this thing that we're identifying, which in this case happens to be personnel, which we coined the word midfix. You got the prefix, got the suffix. This is the midfix. So we're telling you what this thing is. We also throw in this visual cue here of this leading underscore. This is a convention that we use internally at Morgan Stanley to say, this is an instance of something. It's not a class. It's not a property. It's an instance of a class. So just something to help the person out means nothing to the computer. So we've got this employee is assigned to this organization, and again, this organization ID is coming from the system of record. It means something outside the knowledge graph as well as inside it. And we've got, again, our little leading underscore to say, instant data. So, but the nice thing is, it's clear, it's unambiguous. You know exactly what this triple is saying. This employee is assigned to this organization. You don't know who that employee is unless you have an exceptional memory. And you may not know what that organization is, but you know what's going on in the data. Compare that to if we had used information or meaningless IRIs, where this number, this number is assigned to this number. What does that mean? We don't know. And in the absence of access to the knowledge graph, you're not going to know. And the nice thing about this nice pattern that we promote too is that when you're sitting there working out your queries, they can be a little easier to write. You're not having to add in an extra line to say, oh, I want to make sure I get the pref label or the name or whatever to tell me what this thing is. It's just there in the results, which come out in a tabular form, which then leads to the second point is spurious results will stand out. So if I was writing a query and I was expecting only to see something about employees, and I'm looking down this column and there's a thing here about software agent. I didn't want that. So now I'm told, I know that I either need to tighten up my query or we've got a data quality problem. But the point is this visual cue has surfaced an issue that you would never be able to find if you were relying solely on meaningless IRIs. When you are bringing data in from multiple sources, as pretty much everybody does, that means you're going to have multiple IDs for the same thing. It's inevitable. In Morgan Stanley, an employee will have a badge ID, their user ID, their accounting ID, and there might in some instances be other IDs, but these three we know everybody's got. The thing is, when you look at system A and they're talking about employees, they may be using the computer user ID. And over in this other system, they're using the badge IDs. And in some of them, they're using the employee email address, which can also be treated as an ID if you really want to go that route. But the point is, you're going to have to deal with that. And fortunately, the core inherited a way to do that from GIST. We've got an ID class, and we have a pattern that we promote for doing this. So you create instances of IDs that are identifying these various different identifiers. And I know that ID and identifier, it's a really hairy bunch of sentences here, and I apologize, but there was not much of a way around it. except to give you an example. So here we are back with personnel 09264 or whatever. And so there's the statement, that they're personnel, they're in the personnel class, and this person is identified by the personnel ID with this string, the user ID with this string, and the payroll ID with this string. And elsewhere in the knowledge graph, we will have triples about each one of these IDs saying things like, number one, it's a member of the ID class. Number two, it came from system such and such. What if there's an end of life or expiration date on one of these? You could say that. Just extra things you can say about the ID because we are treating it as an independently existing thing. We're not just taking this string and saying this person's identified by the string, because when you do that, that's the end of all you can say about the ID. But by making it a thing unto itself, now it's you can say additional things about it. All right. So now, before I move on to this, are there any questions about the stuff I've gone into? I know it's drinking from the fire hose, and I'm not sure how I'm doing on time. I think I'm actually running out of time here. So 3 minutes. All right. I'm going fast. All right. So one of the other things that we did that I think gave great credibility within Morgan Stanley for semantics and knowledge graphs was after we'd been there a couple of years and we had multiple knowledge graphs and we had a bunch of data in and everything, we were still using the triple store in that XML database. But it was kind of limited in some things that you would expect to be able to do. And so Morgan decided they wanted to buy a built-for-purpose triple store. So they did their research, they decided which one they were going to buy, they bought it, they installed it. And the important thing was that because the data that we had in the existing triple store was all compliant with the W3C standards, and because the new triple store is designed to work with the W3C standards, we were able to, after the triple store is installed and configured, which is anybody who's gone through this knows is the real hard work, we were able to move all of that data, those multiple knowledge graphs, multiple years of data, from one to the other in a matter of hours. And if you were to contrast that with that kind of experience moving from one relational database platform to another, that latter is such a headache. No wonder people try not to do it. So we've been at Morgan Stanley for 7 years. It seems like every 6 or 9 months, some new organization pops up and says, hey, we're interested in this knowledge graph stuff. So we have knowledge graphs that cover a wide variety of different domains here. We've started in information management, various risk management types, the operational compliance and cyber risk, fighting financial crimes, doing fraud analytics, business continuity, equities research. That's the bit where Morgan Stanley analysts go in and say, we expect Nike to go up and Microsoft to go down, and that kind of analysis that they provide to Morgan Stanley's customers. That's very different than the rest of this stuff, and yet all of them are built based around the core ontology and those common data sets. And each new domain extends upon the core by 5 to 20%, just depending on the scope that they want to start out with. But then most of them grow over time. And these new knowledge graphs can reuse or expand on the data that the other knowledge graphs have available. And the senior knowledge graphs, as they were, continue to expand. And I bring this point up because when we went in, I thought, okay, semantic arts, we will be here 2.5 years. And by that point, we will have, done what they need. We will have trained people to be able to take this stuff and carry it forward, and they'll say, thank you very much, semantic arts, it's been fun. here we are 7 years later, and the reason is, not that they are solely dependent upon us, but because they just keep thinking of new things they want to do, that they want their knowledge graphs to accomplish. So the client is not locked into a dependency, neither on semantic arts, because we are not their sole source of ontologists. They've hired their own ontologists internally. They have some contractors who are ontologists. We're all working and playing well together. And the semantic technology itself, coupled with the designs and the patterns that we have established and promoted, means that if Morgan Stanley were to say, all right, semantic arts, thanks, it's been fun, see you later, they could do that, and it would not significantly impair their ability to move on. So when we say, we don't want vendor lock-in, we're not talking about just the tech. We think that everything around the knowledge graph should be that free. Most of the knowledge graph firms were built to enhance the data, break down data silos from the existing systems, but we don't go in saying we're going to replace that system, because that's a great way to make enemies. Instead, we're going to come in, we're going to break down silos, we're going to make your data more valuable because it's going to be linking with other things, and more people are going to see it and use it. That's a good thing for you. But we are beginning to see what we're calling legacy erosion, which is new functions. Rather than adding some new functions or some new data or some new features into these old applications, they're going, oh, well, let's put it in the knowledge graph application instead, because that's faster and easier and cheaper to do. And we are beginning to see actual legacy replacement. So even though we're not going in saying we want to replace System X, some of these things are beginning to age out. They want to replace them, and they're going, we've already got a bunch of this data already in these knowledge graph based applications. Why don't we just replace this thing with, expand on something that's there, or build a new one? Because again, it's faster, it's cheaper, than purchasing a replacement or building a replacement in the legacy manner. So I know I'm over by a couple of minutes, but this 7-year successful journey is based and predicated upon the use of a shareable core ontology, consensus governance of that, coupled with a loose collaboration between the domains and their ontologies, providing guidelines but not laws that encourage human-friendly designs, shareable refreshed data, reference data, and then adhering to the W3C standards to prevent lock-in. Questions? Okay. Somebody wants to take a picture. Yeah, okay. If there are no questions, then I know it's the last thing. So, run, Forrest, run.
In order to make that like a system, some of the representations have to be executable. So do you have definitions of executable things so that the ontology becomes executable itself? Or is it just the definitions and then you layer in code in behind those definitions? How do you use it with a development framework?
I'm not certain I understand the question well enough to answer it, but that gentleman over there probably can.
If I heard you correctly, there's a lot of things you do with modeling that checks whether the ontology is logically valid. So you run these research, it will tell you if you've done something kind of crazy, in a way that a traditional system can't even think about it. So there's some of those checks. We also have a pipeline where we run kind of equivalent unit tests. Is the data valid, and there's cardinality constraints that you want to check and things like that. So there is a whole.
Yeah.
In fact, we're starting to call it SemOps now. It's sort of like DevOps, but for semantics.
Also, if if the application you want to build is going to be like a rules-based system, capture the rules in the knowledge graph.
Yeah.
So then it becomes operable, if that's the kind of sense you meant.
Well, that's sort of that idea that we're getting, because I mean,
Yeah.
like, there's.
Well,
when you think
can
about
there was a young lady back there who had a question somewhere. Yeah.
I just want to ask if when new orgs or subdomains come out of the woodwork, is there a standard onboarding process that you have for your employees?
Sorry, could you say a little louder?
Is there a standard onboarding process that you use when new organizations come out of the woodwork?
There are some things that we ask for, that business. Oh, I'm sorry. The question was, when we go to a new client and we're going through a kind of onboarding with them, do we have a standard approach to that? And the answer is, we ask them to identify a certain set of stakeholders on the business side. We really, really want the requirements coming from the business side, not from IT. They have a completely different view of the world. We want to be solving the business's problems. And we ask them to commit availability, time to spend with our people in knowledge transfer, and then later reviewing the products that we create. There are some certain environmental things that we'll want, because we'll want to install the free Protégé tool that we use for modeling. There are some other things that we would bring in that, depending on how rigid your firewall is, we might require permissions and stuff. Let's see. Yeah. Yeah, the biggest speed bump that we have consistently found in the last few years is, we go in and we say, oh, okay, to do what you want, they've identified these certain data sets. This is where we can get that data. Getting access to that data, getting extracts from that data, sometimes turns into a nightmare. So, we ask for people, to commit to diligently pursuing that, and not saying, oh, here's a user ID to that database, you can query it yourself. No, thank you. Anybody else? Thank you so much for sticking it out. I very much appreciate it.